Hello again, everyone. This is Mr. V. Hill, and today I'm going to talk to you a little bit about what's called point-slope form, as opposed to slope-intercept form that we talked about last time. And so the idea behind point-slope form here is that we know that 2 points determine a unique line, meaning if you're given 2 points, there is only one line that will pass through both of those points. Or, alternatively, 1 point and a slope will also determine a unique line. For example, suppose we have a point 1, 3, and we know we want a line with slope of 5, 2 going through that point. Well, it's pretty simple here. Here's the point 1, 3, and then if we follow the slope of 5 halves, that's a rise of 5 and a run of 2. Let's see here, 1, 2, 3, 4, 5. We rise 5. And then we run 2, 1, 2. We're going to end up right here at a second point. Amazing, right? So 1 point in the slope really gives us 2 points. Great. And then once we have our 2 points, after following our slope of 5 halves, then of course we just connect those 2 points, playing connect the dots here, and there is our line. Wonderful. But just having the picture of the line is great, but we also want to have an equation for the line. And that's where this point-slope form comes in. We're talking about point-slope form for the equation of the line. And so the idea here is that no matter what 2 points you pick, when you calculate the slope, it's always going to be, between the 2 points, it's always going to be the same. And exactly 5 halves. So, here's the point 1, 3. And let's just say, let's pick any point out here, but we'll just call it an arbitrary point x, y. So if this point xy is on the line, then when we calculate the slope between this point and 1, 3, we'll get 5 halves. And we know how to calculate the slope. It's the difference in the y-coordinates divided by the difference in the x-coordinates. So we take the y-coordinate of the second point, y, and we subtract the y-coordinate of the first point, 3. We divide that by the x-coordinate of the second point minus the x-coordinate of the first point. And that will be equal to 5 halves. Okay. So really this is an equation for this line, meaning that if a point is on the line and we plug the x-coordinate of that point in here and the y-coordinate of the point in here, this will turn out to be a true statement, meaning you'll get 5 halves equals 5 halves. If the point is somewhere over here, not on the line, we plug that x-coordinate in here and the y-coordinate in here, and we just do a little simplification, then we'll get something completely ridiculous like 18/7 equals 5 halves. So that would tell us that that point is definitely not on the line. So that's how this equation right here is an equation for this line, meaning it's a good name for this collection of points. And so this could be called point-slope form, because we're using 1 point, the x-coordinate here is 1, the y-coordinate is 3, and the slope, 5 halves. But we're going to simplify this a little bit. Well, not really simplify, we're going to modify it a little bit. And so what we're going to do here is we're going to take this denominator, which is really in parentheses because of the vinculum here. It's a grouping symbol. And we're going to multiply both sides of the equation by this denominator. Reason being, now we have the same thing in the denominator and in this numerator here, so those will cancel each other out. And we can rewrite the equation, and it'll be y minus 3 is equal to 5 halves times x minus 1. And this is the traditional version of point-slope form. It's y minus the y-coordinate of the point that you know, is equal to the slope times x minus the x-coordinate of the point that you know. Might call this old school point-slope form. Right there. Or, since we can't plug this into the calculator, since we have y minus 3 over here, we need to get y all by itself. What we might do is just add 3 to both sides. Of course, this would cancel out over here, and we just end up with y is equal to 5/2 times x minus 1 plus 3. And now we have y all by itself. We can punch this into our calculator and graph it, and that's all fine and good. This we might call new school point-slope form. And either one is fine. This one is a little bit easier to remember, kind of, just because you're always subtracting the y-coordinate from the y variable and subtracting the x-coordinate from the x variable. Whereas here, it's y is equal to the slope times the x variable minus the x-coordinate of the point that you know is on the line, and then plus the y-coordinate of the point that you know is on the line. And this one has some nice uses too, just looking at these things as transformations. We're not going to get into that right now, but we might have some time later. So, in general, this is what point-slope form is all about. If a line contains the point x sub 1, y sub 1, and has a slope of m, then we can write an equation in point-slope form either this way or this way. Notice y is equal to the slope m times the quantity of x minus the x-coordinate of the point that you know is on the line plus the y-coordinate of the point that you know is on the line. Or the y variable minus the y-coordinate of the point that you know is on the line equals the slope m times the quantity of the x variable minus the x-coordinate of the point that you know is on the line. Either way works just fine. This way just is a little bit easier to punch into a calculator, but they're completely equivalent. Okay, so let's do another quick example just to show you how we can use this. So here we want to write an equation in point-slope form for the line containing these 2 points, -2, 4, and 7, -3. So if we have 2 points, that determines a unique line, and so we could just go through like we did before and figure out what the slope is and then figure out what the y-intercept is and write it in slope-intercept form. But point-slope form is really, really easy because we don't need to find the y-intercept. We do need a slope though, right? In point-slope form we need a point, which we know 2 of, more than enough, but we also need to know the slope. So first we got to find the slope. But we know how to calculate the slope. Easy is the y-coordinate of the second point, -3 minus the y-coordinate of the first point, 4, all divided by the x-coordinate of the second point minus the x-coordinate of the first point. Do a little simplification. -3 minus 4, that's a -7. And 7 minus a -2, that's 9. And now we can just take either point and plug it into our point-slope form. If we want to do the old school version, we'll take this point here and we say y minus the y-coordinate that we know is on the line. That equals the slope, -7/9, times the quantity of x minus the x-coordinate of that point that we know is on the line. So that's the old school version using this point. Or if we just add 4 to both sides, then we get y is equal to -7/9 times the quantity x minus -2, and then we add 4 to both sides to cancel that one out, and there's the new school version. If we wanted to, we could change this subtracting the -2 to adding +2. And that's totally fine in either one. It doesn't really matter. Or we could use this point instead. Not a big deal. The equations will be completely equivalent. So it would be y minus the y-coordinate of the point that you know, -3, is equal to -7/9 times the quantity x minus this x-coordinate of 7. There's the old school version. Or we could add -3 to both sides, and we end up with y is equal to -7/9 times the quantity x minus 7 plus -3. And there's the new school version using this point. And we can check to see if we did this correctly as well. If we just want to punch this in our calculator really quick, let's try this one. Now I can't use this one because the calculator demands that we have y all by itself. So let's see here, we've got y is equal to, I'm going to use some parentheses just to keep things straight, -7/9 times the quantity of x minus a -2 plus 4. Now I'll bring up a table of values, and let's see here, we have the point, oh yep, there's our point -2, 4 right there. And then let's go down here, oh, and there's 7, -3 also on our line. Great. So we know this is definitely the equation for the line containing these 2 points, because there's only one line going through both of these points. Or, let's try this one. Of course, we have to use the new school version. -7/9 times the quantity of x minus 7 plus -3. Again, we'll bring up our table. There's the point -2, 4. And we scroll down some more until we get to 7, -3. Both of those points are on our line. Great. So we see that both of these equations definitely work. These are valid equations for the line containing these 2 points. So here's some practice problems. Go ahead and go do those right now. And if you got your calculator, you can even check to see if you did them correctly. And so we'll go over these in class. Thanks for watching.